This is an example of using the combined gas law in a situation where you're changing conditions. The question says that you have a basketball inflated in a garage at 25 degrees Celsius, and it is inflated to a gauge pressure of 8 psi, and that's the pressure above atmospheric pressure. You then go outside and use it in the driveway to play basketball, where the temperature is minus 7 degrees Celsius. And they want to know what is the actual pressure, which is the absolute pressure, but they also wanted to know what the gauge pressure is. So when you look at this, it's always useful to make sure you know what PV, N, and T are, or what the situation is for those. So the initial pressure is 8 psi, and I'm going to put a G after that because that represents gauge pressure. You are not given the volume, so you want to assume that that's constant. You are not given the number of moles. You want to assume that's constant. And you know that you're starting out at 25 degrees Celsius and you're going to end up at minus 7 degrees Celsius. Well, everything that goes into the gas laws needs to be in absolute units, and Celsius is a scale. Gauge pressure is also a scale. To turn a gauge pressure into an absolute pressure, you need to add atmospheric pressure. And if atmospheric pressure is not given, you will use the normal atmospheric pressure. So we need to add 14.7 psi to this. And that will give us a total of 22.7 psi as our absolute pressure. And we want to know what the final pressure is, both in psi gauge and in just regular psi. Temperature, we need to add 273, so this ends up being 298 Kelvin, and adding 273 to this, we get 266 Kelvin. Kelvin temperatures will always be positive. When you set up the problem, you have PV over NT initial equals PV over NT final. You need to realize that both the V and the N remain constant, so you've got P over T is equal to P over T. By the way, this is Gay-Lussac's law. We will put in those absolute values. 22.7 over 273 is equal to our new pressure over 266. We're solving for pressure, so we're going to multiply both sides by 266, and our pressure will equal 266 times 22.7 divided by 273. So putting this in the calculator, 266 times 22.7 divided by 273 equals, and we get 22.1. Now this is PSI. To get it back to a gauge pressure, we need to subtract atmospheric pressure. So we'll subtract 14.7, 7.4. So we have 22.1 and then 7.4 for our PSI. But notice, to go from a gauge pressure to absolute pressure, you're going to add atmospheric pressure on, and then to get back to the gauge pressure, you will subtract atmospheric pressure. A gauge pressure will be less than absolute pressure.